Hello everyone. Today's topic is recurrence relation. Basically, a recurrence relation is an equation that expresses an in terms of a naught up to a to the power n. A sequence is called a solution of recurrence relation if its terms satisfy the recurrence relation. For instance, the relation Fn is equal to Fn minus 1 plus Fn minus 2 of Fibonacci numbers is a recurrence relation. Now, recurrence relation can be homogeneous, non-homogeneous. First of all, we'll talk about linear recurrence relation for constant coefficient. In linear recurrence relation, there is homogeneous and non-homogeneous. In linear homogeneous recurrence relation, there are methods for solving recurrence relation are iteration method, characteristic root method, and generating function method. The equation, first of all, we'll take the equation of recurrence relation. The equation of recurrence relation is An is equal to C naught An plus C1 An minus 1 plus C2 An minus 2 up to Ck An minus k is equal to Fn. If it is homogeneous, Fn is equal to 0, and if it is non-homogeneous, Fn is not is equals to 0. So here we will take homogeneous solution of recurrence relation by using characteristic root method. Let us see characteristic root method. In characteristic root method, there are distinct roots formula, multiple root, and mixed root. These are the methods for homogeneous recurrence relation, and this is characteristic rooted. You will get the roots like distinct roots, multiple roots, and mixed roots. First of all, we will take the example of distinct roots. Suppose the equation is like An equal to An minus 1 plus 2An minus 2, where n is greater than is equals to 2. Here the order of recurrence relation is 2. Basically the order is highest and lowest term difference. So we will substitute an is equals to r to the power n. Then your equation will become r square minus r minus 2 is equal to 0. Then we will solve this quadratic equation. R square minus 2r plus r minus 2 r minus 2 plus 1 r minus 2 is equal to 0. R minus 2 r plus 1 r is equals to 2 and minus 1. So roots are 2 and minus 1. Basically you can see the roots are distinct. So the formula for distinct roots is an is equal to b1 r to the power n plus b2 r to the power n, or you can say r1 to the power n and r2 to the power n. Now putting the roots in this equation, we will get b1 2 to the power n plus b2 minus 1 to the power n. Here b1 and b2 are the constant. We can find out the roots of b1 and b2 when the initial condition is given. Means the value of an is given, then we can find the value of b1 and b2. Now for multiple roots, we will take another equation. For multiple roots, let us take equation an plus 2 minus 6an plus 1 plus 9 an is equal to 0. Again the equation will become r square minus 6r plus 9 equal to 0, and the roots will be r is equals to 3 and 3. Here the roots are multiple. Now for multiple roots, equation is an is equals to b1 plus, now you can see the multiplicity of the root is 2, means it is coming 2 times, and b2 we will take 2 constants r to the power n. Now putting the value, it will become b1 plus n b2 root to the power n. Then we come to mixed root. Mixed root is a combination of distinct plus multiple roots. Taking another example for mixed root, equation is an 8an minus 1 plus 21an minus 2 an minus 3 is equal to 0. By using hit and trial method, you can calculate the roots of the equation, and the roots will become r is equals to 2, 3, 3. Here you can see the roots are multiple, means 2 is distinct and the multiplicity of root 3 is 2. So for mixed roots, for mixed roots, formula is an is equals to b1 r to the power n plus b2 plus n b3 r to the power n. Basically it is a combination of distinct plus multiple roots. Putting the value, we will get b1 2 to the power n plus b2 plus n b3 plus 3 to the power n. So this is the example of mixed roots. If you get the mixed roots, the equation will be like this. Again, let us take one example. for solving recurrence relation with initial condition -1 plus 2 an minus 2 n is greater than is equals to 2 with condition a0 is equals to 0 and a1 is equals to 1. Now the roots of the equation will be r square minus r minus 2 is equals to 0. Solve this quadratic equation. You will get the roots 2n minus 1. Roots are distinct. Put the value b1 2 to the power n plus b2 minus 1 to the power n. Now, if the initial conditions are given, you can put the value of a0 is equals to 0 and a1 is equals to 1. First of all, take the value a0 is equals to 0. If you put a0 is equals to 0, so you will get b1 2 to the power 0 plus b2 minus 1 to the power 0 is equals to 0 because the value of a0 is 0. So an is equals to 0. You will get this equation b1 plus b2 is equal to 0. This is will equation 1. Again, if a1 is equals to 1, you will get this equation 1 is equal to 2b1 minus b2. This will be equation 2. Solving equation 1 and 2, you will get the values of b1 and b2. Solve these equation, you will get the value of b1 as 1 by 3 and the value of b2 is minus 1 by 3. Now again, for final solution, putting the value of b1 and b2, b1 is 1 by 3 2 to the power n minus 1 by 3 minus 1 to the power n. So this is the final solution of this equation. In the next lecture, we will be discussing the solution for non-homogeneous linear recurrence relation. Till then, thank you for your listening.